In this video, I introduce entropy-driven pre-tokenization for byte-pair encoding. Byte-pair encoding was originally introduced as a data compression to reduce the file size by merging frequent occurrence pairs, and then repurposed for text tokenization. And BPE is a subworld tokenization method in natural language processing due to its excellent performance in large language models and other downstream applications. BPE iteratively merges the frequent character pairs to construct a compact vocabulary so that the machine learning models can effectively capture meaningful subworld units. As a greedy algorithm, BPE begins with the initial vocabulary of individual characters, as shown here. At each iteration, the most frequent pair of symbols, for example, X, Y, that occur adjacently in the corpus and merge them into a new sample Z. The corpus is updated by replacing all the occurrences of X, Y with Z, and the process repeats until a target vocabulary size is reached, as shown here. This original corpus, this pre-tokenized tokens, and this unique characters, this updated vocabulary, this basic tokens, and this merged subwords. BPE operates on pre-tokenized input sequences where initial boundaries are defined by a white space and act as hard constraints on the merge process. However, for an segmented language like Chinese, a pre-tokenization method generates a pre-segmented corpus for naive BPE tokenizer, and merges can occur only within identified spans. The statistical method enumerates every possible n-gram in the corpus and then assigns a utility score to each occurring n-gram. Every n-gram is treated as a candidate W, and his utility score is based on a combination of internal cohesion and contextual separability, as shown here. Where C denote the characters with W, Ci and Ci+1 denotes consecutive characters. Point-wise mutual information measures the associative strength between two adjacent characters computed by using this formulation, where F is corpus frequency and T is the number of n-gram tokens observed in the corpus. Left and right entropies quantify how diverse a span W appears within his immediate context, as shown here. We use this formulation to calculate H left and use this formulation to calculate the H right, where P is calculated from this formulation and this formulation, where L and R indexing the set of distinct characters that can occur immediately to the left with respect to right of W in the corpus. As we here, this is the pseudocode of the method, and this is a typical example. For more details, please check with these references. Thank you. Bye.